So in this session, I want to talk about recursion. So recursion is an amazing concept. It will be used in a lot of data structures that we'll be studying throughout this course. And it happens to be my favorite topic, and I hope it will be your favorite topic as well. Once you go through the next couple of lectures, including this one, I think you'll get very like a lot of clarity on what recursion is, how to use recursion, and how it can make your life very easy. Okay, so if you ask anyone what is recursion, most of the times people will say that recursion is when a function is calling itself. Now, why will a function call itself? I have asked a function to do some work for me and now it's calling itself. That doesn't really make a lot of sense. So why will that happen? Okay, so a function can call itself when the function is saying, okay, you want me to calculate, for example, let's say n factorial. I hope you know what n factorial is. N factorial is n into n minus 1 into n minus 2 up to 1. Right? Multiplication of first n natural numbers is called n factorial. So I want a function to calculate n factorial for me. Now the function is saying, I can do that, but my life will be so much easier if you give me the answer to n minus 1 factorial. If you give me the answer to n minus 1 factorial, I just have to multiply with n. This is the function talking. So the factorial function is saying, calculating n factorial is super easy for me if I know the answer to n minus 1 factorial. I'll just multiply the answer with n and I will be able to give you the answer which is required. Okay. So, and obviously we can calculate n factorial using a for loop, a basic for loop, and keep multiplying numbers for I in range 1 to n plus 1, and we'll be able to do that, right? So I'm taking an example of factorial because the first few examples that I'll be taking, they will all be very simple examples that you can use, that you can resolve, like that you can calculate, you can solve those problems using iteration and without using recursion. Iterative solution is when we are using for loops or basically just iterating through whatever code that you might have written without using recursion so far. Okay. So the first few examples will be because we want to learn recursion, but later examples will be which become so much easier if you're using recursion, which become really hard when you are trying to solve them using iterative methods. Okay. So in case of factorial will say, hey, you want me to calculate factorial n? I will do that, but to do that I will call myself with a smaller input, and then once I have that answer, I'll multiply that with n and I'll have your answer as well. So recursion is when a function is calling itself with a smaller input, which basically is easier to calculate, right? So finding factorial n is a little harder than finding factorial n minus 1. Now factorial n minus 1 internally will call effectively factorial n minus 2 and so on. So this ways we are reducing the size of the problem one by one till it becomes absolutely easy. It becomes absolutely trivial. And when that trivial case is like when we reach that trivial case, we will basically just return the output and we will not call recursion after that. So for example, if I say find 5 factorial for me and then you say, oh, I can find 5 factorial if you find 4 factorial for me, then I say for that I need 3 factorial, then I say for that I need 2 factorial, then I say for that I need 1 factorial, for that I need 0 factorial, then I'll say I need minus 1 factorial, minus 2 factorial. There is no stopping that. So we can't keep going like this. We have to stop somewhere and say, oh, this is very easy. This I already know, so let me just return the output corresponding to 0 factorial. So that if I start from 5, 5 says give me 4, 4 says give me 3, 3 says give me 2, 2 says give me 1, 1 says give me 0, 0 will say, okay, here is your answer. Using that, 1 will calculate its answer and pass it to 2, 2 will calculate its answer and pass it to 3, 3 will calculate its answer and pass it to 4, and 4 will calculate its answer and pass it to 5, which will basically give us the output that we wanted this function to calculate for us. Okay, so that's how recursion is going to work. Perfect. So let's quickly write this factorial code. Okay, so let me quickly create a notebook. Okay, so I have a n which I'll take user input. Great. Now I need to write a function. So we will, in recursion, we'll always using function. You cannot use recursion without actually writing functions. So let's write a function factorial which will get an input. Okay, let me move this just to avoid confusion. Sorry. Wow. Just 1 second. Perfect. So I'll call the function in this cell, but let me write the function here. So what are we saying? I want to say that I want to return n into factorial of n minus 1. But there is a problem with what we have written so far. We haven't given the trivial case. We call that case base case. So we haven't given the base case. So having a base case is very, very important, because otherwise, okay, so let's take an example. I take n is equal to 2 and I call factorial 2. Factorial 2 will say, hey, give me factorial 1. Factorial 1 will say, hey, give me factorial 0. Factorial 0 will say, hey, give me factorial minus 1. That'll say, give me minus 2. That'll give me factorial minus 3, factorial minus 4, and so on. It will never stop. So you'll never get your output. So we need to give that trivial case. We'll give that. But for now, let's just call it without the trivial case and let's see what happens. Okay. So it's asked, sorry, I should not say factorial 2. I want to do factorial n. Let me stop this. Run this again. And it's running, right? It's continuously running. The star here shows that it was running. There was a star here which showed that it was running. It was not done yet. And now it's giving us an error, maximum recursion depth exceeded. This basically means I called 2, went to 1, went to 0, went to minus 1, went to minus 2, and it kept going, kept going, kept going. And there is a limit to how deep you can go in recursion. Till how long you can keep going, there is a limit to that. There is a limit because there is memory use, right? So when 2 is waiting for 1, there is a function which is waiting. And because it is waiting, there is some memory which is used by this. So if you have an infinite number of functions being called, you will require infinite amount of memory, and you can't have infinite amount of memory. So you need to have some restriction of how long or how deep your recursion calls can be. Okay, so by default Python has nearly 1000 depth, right? By default, right? So you can change this and we'll see how to change that, but by default you can go deep up to 1000. At least in my system I can go deep up to 1000. Okay, perfect. So seems like we need to add the base case. If we don't add the base case, the code is not going to work. So base case is very, very simple. Before I make the call, which is factorial minus 1, I just need to say if n is 0, return 1. Right? That's the base case. If it is 0, then I don't have to do anything. 0 factorial is 1. That is by definition. So let's run this again. Let's give it 2, and we get the output very quickly, which is 2. 2 factorial is 2, 5 factorial is 120, and that's exactly what we are getting as well. Okay, so I hope this is clear, right? You could have, there was no difference. I could have written this function, the same function, in a little different way. Let me call it factorial 1 for now. I could have said small output is equals to, there is no difference in the above function and this function. right? I could have said this, but that doesn't really matter. So what am I saying? I'm saying I want to call factorial n minus 1, whatever is the answer, I'm going to use that answer to multiply with n. And that's the same thing here as well. Doesn't matter, right? So both of these functions are exactly the same. So now you know how to write factorial. In the next session, we will actually talk about what exactly is the math behind recursion and why does it actually work. Okay, thank you.